In this example, we're also going to be graphing a compound inequality, but now we're going to do OR. The last example was AND, when we graphed both of them and we only shaded where they're both true. Now we're going to do, well, we want to know when is it true for the first inequality or the second one. So most of the graph is going to be shaded. There'll only be a small section that is not. So let's go ahead and graph these guys. And the first thing that we have to do is write these in slope-intercept form. So I'm going to go ahead and start that over here. So 3x plus 2y is less than 6. So I'm going to go ahead and write this in slope-intercept form. So I'm going to subtract 3x. And I get 2y is less than negative 3x plus 6. And then I'm going to divide everything by 2. So y is less than negative 3 over 2x plus 3. All right, and then we're going to do the other guy over here. X minus 2y is greater than 2. I'm going to write this now in slope-intercept form. I'm going to subtract x from both sides. And then negative 2y is greater than negative x plus 2. And then I'm going to divide both sides by negative 2. So I have y, notice that I just divided by negative. So this is going to go from a greater than to a less than a half x and then minus 1. Okay, so this right here is a 1 over 2, right? 1 over 2, and then positive 2 divided by negative 2 is negative 1. So these are the two guys that we actually want to graph and then shade. So let's start with the first guy right here. So we have a y-intercept of 3, and we have a slope of negative 3 over 2. So down 3 over 2. Awesome. Down 3 over 2. Down 3 over 2. Down 3 over 2. And we can go up 3 over 2. Up 3 over 2. Cool. So since this is less than, it does not have a line underneath it. It's going to be a dashed line. So let's go ahead and do that there. So there's that. And my shading is going to be below because it's less than. And again, like this is what I'm using right here. So I'm just going to do lines like this. Great. Now let's go onto my other graph here, and I'll do that in blue now. We have a y-intercept of negative 1. Oops. Negative 1. And we have a slope of 1 over 2. Up 1 over 2. Oh, they intersect right there. That's nice. Up 1 over 2. Up 1 over 2. Up 1 over 2. I could do down 1 over 2 as well. And that's also going to be a dashed line. And this shading is going to be below, right? Because it's less than, so it's going to look like this. Okay, and so the yellow pertains to our first inequality, and this pink right here is going to refer to our second inequality. So what this means is that the OR, again, the OR means either one. Either when is it true for the first one or the second one? So all this shading right here means that if you pick a coordinate point, it will either be true for the first one or the second one. Where they combined right here, this is the and all of it is the OR. And that's it.